Hi, today we're going to go through the second paper from the PAT paper from 2016. So question 2 says, we're asked to solve root 3 tan squared theta minus 2 tan theta minus root 3 equals 0 for theta greater than equal to 0 less than equal to 2 pi. So what we notice is that we actually have a squared, a linear, and a zero power term. So what we do is we're going to let x equal to tan theta, and then it will be clear to see that we get root 3x squared minus 2x minus root 3 equals 0, and therefore we have a quadratic. So what we do is we're going to use our quadratic formula. So this is our a term, this is our b term, and this is our c term. So we know the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So plugging that in, we get that tan theta or x is equal to minus b, that's minus 2, so that's 2, plus or minus the square root of b squared, that's minus 2 squared, so that's 4, and that's minus 4 times a, which is 4 root 3, times c, so that's minus 4 root 3 times minus root 3, which gives us plus 4 times 3, all divided by 2a, which is 2 root 3. Well, that's equal to 2 plus or minus the square root of 16, or plus or minus 4, divided by 2 root 3, which is equal to 1 plus or minus 2 over root 3. And therefore we see that tan theta is in fact equal to either 1 minus 2, so that's minus 1 over root 3, or tan theta equals to 1 plus 2 over root 3, 3 over root 3, or just root 3. Okay, so what values of theta correspond to these numbers, root 3 and minus 1 over root 3? So let's just sketch quickly a very small sketch of tan theta between 0 and 2 pi. So it has an asymptote at pi by 2 and at 3 pi by 2. And it's got a period of pi. So it comes up like this, and then it comes up like this, down through pi and up here, and like so. So root 3 is going to be somewhere up here. So we see we're going to have two values of theta that correspond to root 3. And then minus 1 over root 3 is going to be somewhere down here. So again, we're going to get two values of theta that correspond. So what values of theta give us root 3? Well, we know that pi by 3 gives us root 3. Tan of pi by 3 is root 3, so we get theta is pi by 3. Well, then we have to think, well, what's this value here? Well, we know tan has a period of pi, so simply this value plus pi will give you this value. So pi by 3 plus pi gives us 4 pi by 3. Then what's this value here? Well, we know that we need a negative value of sine or cos, one of the two, so we need a minus value. And we know that 1 over root 3 corresponds to tan of 30. So let's think about this. So if we just quickly have a look over here, our cos graph looks like this. So we know tan of 30 is up here somewhere, and we want a negative value, but we want the same modulus, so the same number but negative, and that will correspond to down here. So this here is pi, and this is pi by 2. So we know that this is pi by 6, 30 degrees. So simply our answer is pi by 2 plus the difference between pi by 2 and pi by 6, i.e. pi minus pi by 6. So that's 5 pi by 6. And then, again, we add pi, because it's repetitive with a period of pi. So 5 pi by 6 plus pi gives us 11 pi by 6. Just to clarify that, these two ones I think were obvious. So the pi by 3 we should know is the answer to give us root 3. Then we see it's a period of pi to add that on. And then we got the 5 pi by 6, and the fact that we know that tan of pi by 6 is 1 over root 3. And we know sine is positive within the range of 0 and pi, but cosine goes negative. So we think, well, we need the same modulus, but it to be negative. So we come down here, and we see it's pi by 6 here, so we pi minus pi by 6 here. So that gives us 5 pi by 6. And then simply to get this value here, we added pi to this because the period is pi. And this gives us our answers.